Hi everybody, I hope you all are doing great. So the next question we are going to see in this DP series is that type of a question which may look very difficult at first sight, but it is actually very easy when you try to solve it and try to do it like solve it on pen paper first, right? Let us read the problem. Ways to tile a floor. It is a very famous problem. Let us see what it's saying. Given a floor of dimensions 2 cross W, okay, a floor is given to us, dimensions are 2 cross W. So two rows will be there and W columns will be there. Okay. And tiles of dimensions 2 cross 1. So tiles are of dimensions 2 cross 1 only. Okay. The task is to find the number of ways the floor can be tiled. A tile can either be placed horizontally as 1 cross 2 or vertically as 2 cross 1. Print the answer modulo 10 to the power 9 plus 7. Don't worry about this right now. We just have to worry about this much question right now. So this is what the problem is saying. As you can see, when W value is equal to 4, I will say that it's N value. Let's say 2 cross W they are saying, I'll say it is 2 cross N, right here. They're saying 2 cross W, I'll say that it's 2 cross N because N is a pretty familiar variable to us. And yeah, so W, let's say is 4. Let's say N is 4, then the answer should be 5. So there are 5 ways to tile a floor of dimensions 2 cross 4. 5 ways to tile a floor with dimensions 2 cross 4. Let us analyze on the board and then we will get more insight on this question that how to approach it. So when they're giving us n is equal to 4 or w is equal to 4, they're essentially giving us a floor with dimensions 2 cross 4. Correct? This is clear that how the floor is looking like. This is the floor is looking like. This is how the floor is looking like. And how are we having tiles? We are having an infinite supplies to tiles like this. 2 cross 1. This type of tile I am having an infinite supply to. We draw 2 cross 1 tile. So this is a 2 cross 1 tile. And of course, since this is a 2 cross 1 tile, I can either place this tile like this only, or I can also rotate this tile and place it like this also, right? 1 cross 2 as 1 cross 2 as well, right? So a tile can be placed like vertically or horizontally, right? 1 cross 2. Right? So this is what tiles we are having. This is the floor we are having. I have to tile this floor in different ways. I have to count those number of ways that in how many ways I can floor this tile. Let us look at an example of n is equal to 4 and then we'll more closely understand that what are the different ways of tiling this floor. So I have drawn some in 2 cross 4 type of floors. These are the dimension of different floors I've drawn here. I'll fill tiles in this floor and I'll show you how many different ways we are having to floor this tile. So let's say I'll place all the tiles like this. Let's say I'll place all the tiles horizontally. Sorry, vertically. So I'm placing all the tiles like this. Have I completely tiled the floor? Yes, definitely. I have definitely done that. Okay. Let's try to place all the tiles horizontally now. I'll place this tile horizontally here. Here also I cannot fill a vertical tile, right? I have to fill it with horizontal only. So I'll fill it horizontal. Let's say I'll fill this tile also as horizontally. This tile also I'll fill it horizontally. Okay. Let's say here I'll fill two vertical tiles and then a horizontal tile. Okay. This is also another way to tile this floor, right? All the tiles are definitely of 2 cross 1 dimension only. I'm just rotating. Either I'm placing like this or I'm placing like this. And of course, we are having an infinite supply of tiles, right? This is the third way we have found to tile this floor. So let's say instead of vertical tiles here, I'll place horizontal tiles here. And I'll place two vertical tiles here. This is another way to place these tiles. I'll take some extra area as well. Let's say I'll keep it here. So let's say I want to fill this with different way. Is there any other way I can fill this with? Let's say I'll fill this with horizontal. Let's say here I'll fill with here I'll be vertical. Here I'll fill with horizontal, and here I'll fill with vertical again. This is another way. Let's try to explore and find out that if there is any other way to fill this floor, to tile this floor using different ways of tiling. Right? I'll fill this with horizontal, right? And I'll fill this with horizontal, and I'll fill this with horizontal. Can you see that these areas are remaining, and these cannot be because we cannot break the tiles. We cannot break the tiles. I cannot simply break a tile and place it like this. No, I have to consider the whole tile completely, right? So you can see that this is not a possible way to fill the tile because of these extra areas which are remaining, right? I have not placed any tiles on these areas, right? This is a wrong method. If I place a tile like this and I place a tile like this I cannot place two vertical tiles here, right? Because this is exceeding, right? And I cannot break the tiles. I have to place it like this, and this we have already covered here. So I'll not count this as another way as well. So in all, are like, is this point clear that we cannot place any other we cannot place the tiles in any other format to tile this floor, right? We cannot place any other format of tiles to tile this whole floor, right? So when n value is 4, you can see there are 5 different ways to tile this floor. And this is what the question is asking. If you are having any type of floor, like let's take another example. Let's say n's value is 2, right? Let's say n's value is 2. Okay. So let's say n's value is 2. This means that this is kind of 2 cross 2 kind of a area I'm having here, right? Now in this area, can I simply say that, this is 2 cross 2? I'll fill this with horizontal tiles, I'll fill this with vertical tiles. So when n's value is 2, you can see that there are only two ways to two different ways to tile this floor, right? Let's say n's value is let's say 3. So when n value is 3, you can say that the floor is looking at this. Like, only the question language is difficult. The question, when we are going to solve it now, it is very easy. It is just a simple observation which is required to solve this question, right? Just give me a second. I'll okay. Here, let's analyze n is equal to 3. Okay. So I can fill the floor like this, tile the floor like this with all vertical tiles. Can I place horizontal tiles here? Possibly. I cannot place horizontal tiles like this, but I can definitely place horizontal tiles like this and then a vertical tile, right? And one more thing, let us bring them here. Okay. So is there any other way? I can definitely place vertical tile here and two horizontal tiles like this. And you can see, other than these ways, there is no other way to fill when n is equal to 3. When n is equal to 3, these are the three possible ways to tile this floor, right? So I think it is pretty much clear to everybody that when n is equal to 2, this is the floor we are having 2 cross 2, and these are the two ways. N is equal to 3, there is only this way. Let's say when n is equal to 1, how many ways would be there when n is equal to 1? You can definitely pause the video and think that when n is equal to 1, the floor would look like 2 cross 1, and only one tile can be placed here and no horizontal tiles can be placed here. So when n is equal to 1, there is only this way to fill this tile, right? So I think it is clear to everybody that these test cases of n is equal to 4, right? N is equal to 4, how many ways we are having to fill the tiles of n is equal to 4, right? These are n is equal to 4, these are n is equal to 3, these are n is equal to 2, and n is equal to 1, right? So I think it is pretty much clear that what are different ways, what do we mean by different ways of tiling a floor. Let us quickly move to some observation in order to solve this problem itself. The observation here is very peculiar, that when we are placing a tile of vertical, you can say rotation, when the tile is vertical, right, I can place another tile in the next, you can say, column itself, right? And I can place another tile in the next column itself. Definitely, tiles are vertically placed, right? But when I'm placing tiles horizontally, can you definitely see that whatever n's value I'm having, but number of rows are only 2. Number of rows are only 2. If I've placed a horizontal tile here, can I place a vertical tile here? No. Can I place a vertical tile here? No. This means that whenever I'm placing a horizontal tile, I'm only having one way to fill this thing with the horizontal tile itself, right? So can I simply say that vertical tile comes like this as a single tile, but horizontal tiles, whenever I'm placing, it looks like this, right, as a double of tile. And like, there is no other way to fill this row of 2. If I've chosen the horizontal tile to fill the bottom row also, like, there's only one option to fill it with horizontal itself. So what I'm trying to establish here, that whenever we are filling anything with a vertical tile, it is a vertical tile, simple. But when something I'm filling like horizontally, I have to consider it only in this format of two horizontal tiles, right? Vertical tile is coming single because it's covering only one column. But when I'm placing horizontally, right, and the number of rows are limited to 2 only, that is given in the question itself. This means that horizontal tile always comes in this, you can particular format, right? If we cannot place something like this, we'll never be placing something like this. It will never happen, because if I have to place something like this, I have to fill these empty areas, and if I want to fill these empty areas, I can only do is vertical tile, but I'm limited to 2, you can say, rows. This means that I cannot fill this area. I hope this is clear to everybody, that we are limited to 2, you can say, columns, right, 2 rows. They're limited to 2 rows. And if I've filled something like this, these are the 2 areas which are remaining empty, right? Now you might think that can't we place something like this? But then this area is remaining. Can't we place something like this? Right, let's say it is let's say this is the n value, let's say these are the floor I am having. You can say this area, this particular area and this particular area is still remaining empty. I cannot fill this area. If I want to fill this area, I have to either have another, can say, column here, but still, if this is the 0th column itself, this 1 cross 1 block will always remain in the starting and in the end itself. So we'll never be filling horizontal tiles like this. Whenever I'm trying to I'm trying to fill any horizontal tile, it will always come in a pair of two adjacent horizontal tiles. Is this point clear to everybody? Yes or no? Vertical tiles come as single, horizontal tiles come as a pair of adjacent two horizontal tiles, right? Let us move to some approach using this observation itself. I think this observation is not very clear to you right now, but when we look at the approach, it will get, you'll completely understand this. Let's move on to the approach itself and then we'll continue with the code itself. So this table I have drawn here. How many ways can I tile the floor when I'm having n is equal to 1? There is only one way. When n is equal to 1, I can fill the tile like this only. Yes, I'll fill the tile like this only. Correct. Okay. All right. When n is equal to 2, how can I fill the tiles? If I add a vertical tile after n is equal to 1, can I simply make of length 2, width of length 2? This is, I am placing another an vertical tile in front of all the ways I am able to make n is equal to 1. Have I made it of 2 width? Yes, definitely. Yes, definitely. And in n is equal to, we definitely know I can also place a horizontal tile as well, like these two horizontal tiles. So these are the two ways to fill n is equal to 2, right? Okay, all right, no issues. When n is equal to 3, look at this. First, I will try to place a vertical tile on the third position. If I want to place a vertical tile on the third position, can I simply say that whatever ways I'm having, number of ways I'm having to fill n is equal to 2 tiles. If I place a vertical tile in front of all these ways, can I simply say that these are making 2 and I'm having a vertical tile here which is adding 1. So can I say that these are 3 columns? Definitely, right? And also, this is the case when I'm using a vertical tile here. Can I simply say that I can also place it like vertically, like horizontally here? But if I want to place, this is the third row, right? Third column. If I place a horizontal tile here, definitely 2 tiles will come like this. And how much area is remaining behind me? This is a 3, you can say n is equal to 3. So I have to consider this much area. So I have placed horizontal tiles here. Area of 1 is remaining. How many ways can I fill 1? So I can fill only with one way. So I'll fill it like this. I hope the approach is pretty much getting clear to everybody, right? Let us zoom out a little bit and let's try to analyze the case of 4. On the fourth position, let's say I'll consider this much area. I'll expand this a little bit. So let's say I'm having this much area. I have to fill this much area. Like, let's say the floor is looking like this, 2 cross 4. Correct. Floor is looking like this, right? Look at all these, you can say, areas, right? So when I want to fill 2 cross 4, if I want to place a vertical tile, let's say this is 1th, 2th, 3th, 4th. If I want to place a vertical tile on the 4th position, how many places are remaining behind me? 3 places. And in how many ways can I fill these 3 places? Can I simply say 3 ways? You can see that I can fill these places as 3 ways. And of course, I'm using a vertical tile here. So definitely vertical tiles I'm placing in front of all these ways. And these are valid ways to fill 4. Definitely they are. If I want to place a horizontal tile here, let's say I want to place a horizontal tile on the 4th position, I'll place horizontal tile. So when I place horizontal tile, I'll place like this using the observation we have already done. I've placed how many areas are, how much area is remaining? Area of 2 is remaining. In how many ways I can fill area of 2? You can say that this 2 is covering an area of 2. So can I simply say this, that I'll fill the previous area 2 of like this, and here I'm placing horizontal tiles. So can I simply say that these are all the ways to fill when n is equal to 4? Definitely, definitely, right? When I'm using n is equal to 5, when let's consider n is equal to 5 case as well as the last case. So when I'm considering n is equal to 5, can I simply say that if I, let's say 1, 2, 3, 4, 5, if I place a horizontal vertical tile here on the fifth position, if I place a vertical tile on the fifth position, 4 area is remaining. So if I'm placing vertical tile, how much area is remaining? I have covered one column. N is the number of columns. I have covered one column. N minus 1 columns are remaining. So what is the answer for n minus 1? 5 ways. So I'll add this. I'll add this. And of course, here also I'm filling this particular tile, this vertical tile. And when 5 wants to do what? When 5 wants to place a tile horizontally, right? Let's consider this area. So I'll say 1, 2, 3, 4, and 5. Let's say consider this area. If I place a horizontal tile here, if I place horizontal tile configuration here, can I say 3 areas still remaining on my board, on my floor? Yes, definitely. And when I'm placing vertically, whatever ways is n minus 1th person is able to make, that I will add. But when I'm placing horizontally, whatever ways, how much area is remaining? N was total area. 2 columns have been covered by this particular horizontal placement. Can I say n minus 2 columns are remaining? So when I want to place tiles horizontally, can I simply say n minus 2 will be having the answer? So you can simply say that 3 areas remaining, n minus 2, 5, minus 2 is 3. 3 areas remaining. Can I place these tiles like this? And then of course, I'm placing horizontally tiles like here. And can you simply see these are all the ways in which I can tile a floor which is having a width of 5 itself. So can you derive a solution out of this? Definitely, yeah. Because you can simply see that it is similar to Fibonacci numbers itself, right? 3 is getting answer from 1 plus 2. It is 3. You can say how many ways are there? 1 is having only one way. 1 is having only one way. 2 is having two ways. 3 is having how many ways? 1 plus 2, 3. 4 is having how many ways? 2 plus 3, 5. Correct. 5 is having how many ways? 5 plus 3, which is 8. So it is kind of Fibonacci numbers itself, right? Because when I'm placing horizontally, I'll have to consider n minus 2th answer. When I'm placing vertically, one column I have covered by this particular tile, and I have to consider this from n minus 1 columns, right? So this is the overall approach. I hope this is clear to everybody. We'll not be drawing any recursive diagram itself because it's all we already know, like if we are standing on n, right? If we are standing on n, right, I want the answer where? I want the answer from n minus 1, f of n minus 1, and I want the answer for f of n minus 2 itself, and I'll add both of these and I'll return whatever is my answer, f of n, right? This is similar to Fibonacci numbers itself. We've already seen this tree. Let's quickly code this recursion out, then we'll come over to memoization, then we'll come to tabulation, then we'll come to space optimization. Great. Let's get it. Here we are in the code itself, and what we are going to do, I'll simply return a recur. I'll call a function recur. I'll pass a n here. Okay. Now static long recur, integer n will be passed here. If I want to consider all the ways of filling n, if n's value is equal to 1, how many ways can I tile a floor which is having one width? One way. If n's value is equal to 2, how many ways can I tile a floor which is having a value of 2, which is having a width of 2? 2 columns. I'll return 2. These two answers I already know. These are the base cases, can I say? And after this, can I simply, do one thing? I'll simply consider for, you can say, I'll simply do what? I'll simply integer, if I place a vertical tile here, recur for n minus 1. If I place a horizontal tile here, recur for n minus 2. And in the end, return what? Can I simply return vertical plus horizontal? Right, these are all the ways to fill the tiles itself, and this is the whole recursive code. It's pretty similar to Fibonacci numbers itself. You can definitely say that, right? So n, okay, from long to int, okay. These variables I have to consider them long because the recur return type is long itself. All right. So it's working fine. All right. Now let's convert this quickly to memoization itself. There's no harm in doing that. Right, and I hope it is pretty clear to you all as well. You can pause the video and code it out if you want, right? I definitely don't advise pausing the video and trying to code anything by yourself, but of course in this particular case you can definitely try it by yourself. DP will be of 1D because only one parameter is getting changed, long, because long is the return type of the overall function. So here I'll pass DP as well. I'll first change the names of these. Memo. I'll also change the name of this as memo. I'll change the name of this as me. Right. I'll pass DP here, array here. I'll pass DP array here. Now recall and remember. If DP of n is not equal to -1, return DP of n. If it's not equal to -1, this means that I've tampered with it. This means that I have to return it. Okay. And now what do I have to do? DP of n is equal to vertical plus horizontal. This is it. This is it completely. Let's quickly create DP as well. Bring this a little bit down. Long array DP is equal to new long, and the length will be n plus 1 because nth index I want. That's why I'm taking an extra index, so that last index is the n index itself, right? Arrays dot fill DP with a -1. It will fill all the places of this array with -1. And I'll call here return memo. I'll pass n here, I'll pass DP. Now I'll run this code. It would work fine. It would definitely work fine. But when you submit it, it will not get submitted. Let's see what is happening. It will not get submitted. Memoisation should work, but it's not getting submitted. It's not getting submitted due to any time limit exceeded. It is getting submitted due to some out of bounds, integer out of bounds, something like that is happening, right? And that is why they are giving us this 10 to the power 9 plus 7, right? Whenever integer are going out of bounds, we try to mod it with a big prime number. This is a prime number, right? So I am trying to mod it with a big prime number so that it cycle back to a positive value itself, right? If it is not clear, you can definitely, ask me in the comments, or, we can also make a video on this topic itself, 10 to the power 9 plus 7, if you want, if we can have actually do that. But in short, it is used to, uh, get the integers back in range itself, because if you do something like this, if you do integer max plus 1, you will get integer min, and Java will not give any error, right? But it is going negative, right? But if you take a mod with a very big prime number, yeah, if I take a mod with any number, let's say I take a mod 5 mod 3, can I simply say that result will lie between 0 and 2, 0 and 2 inclusive, right? Because we are modding it with 3. Definitely, I hope this is clear that 10 to the power 9 plus 7 keeps them in the positive range itself, and this is a prime number, so definitely it will keep it in positive range. So what do I have to do here? I'll take, how do we handle this 10 to the power 9 plus 7? Now that is clear that what is 10 to the power 9 plus 7, I'll take a long variable md mod. I'll take 1, 2, 3, 4, 5, 6, 7, 8, and 9. 10 to the power 9 plus 7, this number is 10 to the power 9 plus 7. So whenever I'm returning the result now, I'm simply doing here a mod. Whenever I'm doing that, I'll simply do this. And here also, not only here, I'll do it here also in this overall function itself. Whenever I'm doing this, I'll simply return it with mod. And this will actually handle the case itself. Let us try to run, let's try to run this for now, and then we'll try to submit it. I hope this is clear to everybody that why are we using 10 to the power 9 plus 7, and what is the significance of doing this mod operation. Now it's passing successfully, and yes, it is working just fine. Let's quickly convert this to tabulation itself, and then we'll move forward to space optimization. Now to convert to tabulation, it is pretty easy. So I'll simply do it static long tabulation, integer n I'll pass here, and in long DP I'll pass here. These are the two variables I'm passing here. From where will the loop start and how many loops will be there? Single loop, because only one dimension DP is there. And where will it start from? It will start from I is equal to 1, right? Because base case is that. So for integer, let's say I'll start it with, I'll not consider it I'll consider it with n. So I'll take a capital N here. For int n is equal to 1, n less than equal to capital N, and n plus plus, right? Why am I using n? Because here every time I'm trying to access n itself, right? So I'll copy paste this code. We have copy pasted this code. What do we have to do here? Now wherever return I'm writing, I have to remember and continue. So I'm returning 1. I'll do what? DP of n is equal to 1 and continue. Here I am returning 2. So I'll remember and continue. DP of n is equal to 2. I have remembered the solution, and here I'll continue. Alright. So these are the two cases I'm having. How many? Now this is the condition where we are trying to recall. So I'll remove this. Here you can see that I am having a return statement as well. I will remove this return statement. I can initialize this long out of this loop as well. Let's initialize this loop, this out of this loop itself. So these are the variables I'm having. Now what step is remaining? Long vertical memo. Wherever memo I'm trying to access, I'll try to access DP of this index itself, right? So I'll try to access here what? I'll try to access DP of n minus 1 here, right? DP of n minus 2 here. And I hope it is clear to everybody that why are we trying to access these indexes, right? And I think it is pretty much clear to everybody. DP I'm saving, like storing the answer for. I'll return in what? I'll return DP of capital N here, right? I'll return DP of capital N, and this is the tabulation code itself. Let's try to run this. So return tabulation. I'll pass N, I'll pass DP, and I'll take a mod with it. And let's see if it is working or not. I think it should work, right? Okay, we are given an output of this, so which is wrong. Let's see what is happening. N should start from 1 definitely. It should not start from 2. It should start from 1. This is a mistake I've done. Oh yeah, it's working fine. Let's try to submit this and let's see if it is working. Then we'll move to space optimization. Then we'll wind the video off. And I hope you all are understanding whatever we are studying, because DP, like if DP is getting easy for you, you can definitely tell me in the comment section. More good questions are coming on the way, so stay tuned, right? So talking about the space optimization, you can definitely see I am only considering previous index n-1th index and n-2th index. So if I keep the values of these two things in two variables, right, you can refer to Fibonacci series question itself. That is pretty similar to this only. For space optimization, instead of taking an array, I'll take only two variables, static long space opti, and I'll simply pass integer n here, and that's it. I don't want any DP here. If n is equal to 1, I'll return 1. If n is equal to 2, I'll return 2. Right? So, long previous. So, I'll say f of n minus 2 is equal to n minus 2 is equal to, I'll say 1. Long f of n minus 1 is equal to 2. Now, for integer I is equal to 1, 3. So, f of n minus 2 is 1. This means that n minus 2 is 1. So what is n? It is 3, right? We have to start from 3. I less than equal to n I plus plus. So these are all the cases I want to calculate the answer for. Now what do I have to do? F of n minus 2, f of n minus 1. Long current is equal to f of n minus 2 plus f of n minus 1. This is what we are doing. If I is equal to actually equal to n itself, current is the answer, I'll return current. And if it is not the answer, f of n minus 2 becomes f of n minus 1. F of n minus 1 becomes current, and we'll move forward. In the end, I'll simply return a minus 1. This is just a dummy return. We'll never return from this statement. It's just a dummy return. We'll always return from this statement itself. One thing is still remaining, which is taking the modulus from this operation. So when I want to take modulus, I'll copy paste this modulus code here. And if you are having some doubts in what we are doing in space optimization, just look at the part of space optimization of Fibonacci numbers. It is same as this only, right? So here, where I'm doing any mathematical operation, I'll add this mod operator. I've added this mod operator here, and I think it is fine. Let's run this space optimization code, and then we'll wind the video. Return space optimization, and I'll pass here an n, right? So I don't require any DP here. I'll of course take a mod here. This mod I'm taking just for safe keeping, right? That's the only thing here. It's working fine. Let's try to submit this. And you can definitely see how difficult was the question and how easily we solved this question through. And we reduced it to Fibonacci series, like essentially, right? So ways to tile a floor, another very famous problem we have covered to this, you can say in this series. Many more problems are coming, many hard problems are also coming. So stay tuned for these videos, and I hope you all are enjoying the content. If you are doing so, please support the channel, right? And I'm baffled by what support you are doing right now as well, but of course much support is appreciated. You can of course share these videos with your friends, spread the word, because all I have is my subscribers itself, right? So I hope you all are doing fine, and you are getting through this series just easily, right? And I hope that DP is becoming easy for you all. So thanks a lot everybody for joining. I hope you enjoyed the video. Until the next video drops, bye.